Good morning. We will start session 3 on chapter triangles. So till now in the chapter triangles we understood the criteria for congruency of triangles, and as well we solved a theorem. We understood a theorem and its converse. As well we solved first sum, that is first rider from the exercise. We will continue the exercise and complete the exercise today, the same exercise which we started in our previous session. So first one was completed. Question number 2. ABCD is a quadrilateral. Draw the quadrilateral whatever is given. So with respect to that, A, B, C, D is a quadrilateral. The diagonals of the quadrilaterals are joined. They have all. Let's start writing the given part first. Given in quadrilateral ABCD, right? So what else is given from the given part? Again children, here, hope you remember in standard 8 you had a chapter called Understanding Quadrilaterals, right? So there we studied different types of quadrilaterals, that is square, parallelogram, rectangle, rhombus, trapezium. You again study that this year also. You have to know, you should remember all the properties here, because sometimes in congruency, suppose if you have a parallelogram and a diagonal is joined and asked to prove the triangles are congruent in them, you should know the properties of parallelogram then, right? Side property, angle property, diagonal property. So again, it's just a recapitulation which you have to study, which you have to recall from standard 8 what you have studied in chapter Understanding Quadrilaterals, the properties. In quadrilateral ABCD, they have given AD is equal to BC. AD is equal to BC. We'll do the marking. Also, angle DAB is equal to angle CBA. So angle DAB is equal to angle CBA. So DAB, this angle is equal to CBA, this angle, right? What all we have to prove here? That we have to write in the proving part. To prove, we have to first of all prove two triangles are congruent. Triangle ABD, that is triangle ABD is equal and congruent to triangle BAC. Okay, from wherever. Now if they have asked you to prove the triangles are congruent, and after proving congruency they have asked to prove some sides are equal, angles are equal, it is always understood children that is by CPCT. So this is the first one what you have to prove. Second one you have to prove that BD is equal to AC, which will be done by CPCT. Third one they have asked an angle ABD is equal to angle BAC. Angle ABD, where is ABD now? ABD is equal to BAC. This is proved by CPCT. Now you know which triangles to choose. Start from that triangle. Proof. In triangle ABD and triangle BAC. If you want, you can draw the triangle separately. In triangle ABD is this triangle here. So this is A, this is B, and this is D. With respect to that, this side and this angle is what? Something equal they have already mentioned. Next part, what is which triangle it is? BAC. So BA, I will just draw here. So this is what the another triangle they have asked. So no more confusions children here. So this angle is equal, this side is equal. We know that, right? Okay. So let's quickly begin with whatever we know in these two triangles. First of all, we will write AD is equal to BC. Then angle, which angle is equal? DAB is equal. So DAB is equal to angle CBA. Both together I will write this as given. Now see, now again always in the postulates which we have congruence rule, we have SAS, you have ASA, you have AES, you have triple S, and you have RHS. Let's go on ruling out whichever is not possible. Of course, triple S and RHS will not come only because now already we have one angle and one side. So RHS will also not come because 90 degree is not there. Left is only this. Now we have already one side, one angle equal. Now either we have to search for another angle to be equal, which is not possible because is it possible any other angle equal or any other side equal? Now look for any side if it is there. Angle is not possible, children. So if angle is not possible, then ASA and AAS is gone out because two angles we cannot find. Then what is left? Only side is left. Now what side is that? It should be either equal sides are already mentioned. It's a quadrilateral. So look for a common side. Do this figure share a common side? Yes. A, B, D, and what triangle it is? B, A, C. Is this common side for both? Check. Side, angle, side for this triangle. For this triangle, side, angle, side. Right? So I will write down AB is equal to AB. Common side. Triangle, so over three things are already done. Triangle ABD is equal and congruent to triangle BAC by SAS congruence rule. Now we know that from SAS congruence rule, just close your eyes and write the remaining sides and angles are equal. Why? CBCT. Therefore, BD is equal to AC. Angle ABD is equal to angle BAC. Reason CPCD. Over. Hence the proof. We proved all three parameters whatever they had asked. This is how you are supposed to do it. Now here you need to only search the given things. Now I have drawn a small rough figure of that. It is better you do it. I need not tell each and every time. It's for your understanding. So quickly we'll move to the next one. Main thing is when you draw, identification is very important. You should know. Apart from given, what else you can identify. And remember, until they have given something is parallel, you cannot say that alternate angles are equal or corresponding angles are equal. Why? Because only if the lines are parallel we can go for alternate angles. Come to the next one, third one. So figure is given. Okay, this is O, this is A, D, B and C. According to them, AD and BC are AD and BC are equal perpendiculars to the line segment AB. Show that CD bisects AB. Show that CD bisects AB means actually my figure will not tell that they bisect. They do not look only. Let me draw it in that manner because another side is quite bigger. Okay. So this is A and this is D. So let's first write the given. Given, I will write here now. AD is and BC are perpendiculars to the line segment AB. AD is perpendicular to AB and BC is perpendicular to AB. This much is given. And they have mentioned that one more side is equal, BC is equal to AD. That's all is given to prove. What they have asked to prove? CD bisects AB. That means that is O is the meaning of this midpoint of it bisects CD. The whole line segment is bisecting AB means O is the midpoint of AB and CD. This implies we need to prove that OD is equal to OC and OB is equal to OA. Okay, since it's a midpoint. Let's start. Now children, they have not told that they are parallel. So we cannot say alternate angles are equal here. Though they are perpendicular, but still parallel word has to be mentioned. So proof, choose the triangles for congruency. Let us choose these two triangles. So first triangle is in triangle BOC and triangle AOD. So given I will first write here angle OBC is equal to angle OAD is equal to 90. Reason, AD perpendicular to AB and BC perpendicular to AB. Okay. Let us write the given side. BC is equal to AD. Given. Now, let's again check this part. SSS cannot come, SSS cannot come, RHS, okay, RHS can come, we will see, because the 90 degrees there. Afterwards, we will check with that. Triple S cannot come because we have already one angle there here. Now left is with check, let us go on checking. Let us check if in RHS whether hypotenuse is equal. What is hypotenuse? OD is hypotenuse, but we have to prove OD is equal to OC. RHS cannot come. So now only left is now is another angle or side. Now in this given figure we cannot prove another side equal. No properties, no common side, nothing. That means I cannot use SAS also. The only left is two angles and a side. Check which else angle can be equal. Can I say this angle is equal to this angle? Vertically opposite angles. So I will write here angle BOC is equal to angle AOD, vertically opposite angles. Read children now, angle side, that means this. If you write by ASA congruence rule, according to me it is wrong because it is by AAS congruence rule. Therefore, triangle BOC is equal and congruent to triangle AOD by angle side, or here also angle side by AAS congruence rule. Now since the triangles are equal, corresponding sides, corresponding angles are equal, with respect to the upper triangle, can I say OB is equal to OA? OB is equal to OA, OC is equal to OD. Reason, CPCT. Therefore, O is the midpoint. Please give the conclusion. O is the midpoint of AB and CD and CD bisects AB. Is it very clear what we have written? Okay. So this is how you are proving. So we proved that line CD bisects AB, that is OB is equal to OA, OC is equal to OD. That means O became a midpoint. Let's quickly go with the next one. Sums are simple, that is writers are simple here. If you understand, learn to identify, and this can be practiced only by writing, not by reading. So this is the given figure for the next one. This is B, this is C, this is B, this is A, this is P, and this is Q, this is D, this is L, and this is N. Okay. Just see here, the condition given here is L and M are the two parallel lines intersected by another pair of parallel lines P and Q. So given I will only write L is parallel to M and another is P parallel to Q. That's all is given. That means shall I mark it? This is one pair of parallel line and this is another pair of parallel line. Show that to prove. Triangle ABC is equal and congruent to CDE. Now it is, we even do not know what quadrilateral it is or only parallel lines are there. If parallel lines are there, alternate angles I can prove, children. But how many alternate angles? After that, what should I do after proving alternate angles? For example, now if I choose this and this triangle, Z formation will come. I will say these two angles are equal. Okay, but because it is parallel, now this is transversal, I will tell that common side. That's only one. That means I will get only two criteria. I cannot have two alternate angles here because Z formation will come this side. If I take this Z formation, like if I take this Z formation, there also again one more diagonal is not joined. So I can only consider this parallel line here and this Z formation, one common side. Only with two parameters I cannot prove the congruency, right? So what we should do? Let's go back to the properties of quadrilateral. Now when we talk about a quadrilateral, what is a quadrilateral? It has four line segment. I'm sorry, no sides are equal, nothing. In this quadrilateral we have a square where all the sides are equal. We have a rectangle where opposite sides are equal. We have a parallelogram, opposite sides are as well equal, and the condition here is they are parallel. Opposite sides are parallel. Then we have a trapezium whose only one pair of side is parallel. Now, I cannot give this, I cannot tell this given quadrilateral as a square because condition should be 90 degrees should be there, which is not there. It cannot be a square. It cannot be a rectangle because again 90 degree. Can it be a parallelogram? Why? Because in a quadrilateral, if opposite sides are parallel, which quadrilateral opposite sides will be parallel, children? Square, rectangle, rhombus and parallelogram. But parallelogram is the only one which will not come with a pre-existing condition. Now rhombus has all sides equal, we can't be calling. So only property which will fit here is a parallelogram. So what we can write here is, in given it is written, prove ABCD is a parallelogram because in parallelogram opposite sides are parallel. Reason you have to write, or you can say in a quadrilateral if the opposite sides are parallel, then it is a parallelogram. Done. It is a parallelogram. What property of a parallelogram? In a parallelogram, opposite sides are equal. Right? So now let us see, opposite sides are equal, opposite angles are as well as equal. Now let us see what property of parallelogram can satisfy here. So in proof part, I will choose two triangles. I can only choose triangles with respect to that given. In triangle ABC and triangle CDE. Okay, in triangle ABC, first of all, what I will write here is, now I know that this side is equal to this side. Yes? Okay, let us write. Now see the possibilities here, children. First of all, we know that opposite sides are equal. We will write out that. AB, then let us see whether it is useful or not. AB is equal to CD. It's a given thing. Then, can I tell angle, what is it? B is equal to angle D? Yes, we can tell. So, we only use what sides we have written. I will write here angle B is equal to angle D. Opposite angles are equal. So, what about this? I write here only BC is equal to AD. Reason? Opposite sides are equal. Side, angle, side. Which one? SAS. Triangle ABC is equal and congruent to triangle CDA by SAS congruence rule. Now, do you think this is the only way to solve this sum? If you actually think it in another way, now again, let us rule out whatever we have marked. Can I tell this angle is equal to this angle? Okay, point number 1. So, which angle is equal? Angle B is equal to angle C is equal. Can I also tell that BAC is equal to angle, because these are parallel children, Z formation, ACB, alternate angles. Two angles are equal. Can I, okay, now anything I can choose. I can say this is equal to this, condition is okay. This is equal to this, condition is okay. Or also I can use common side. I have three different things, right? I can also prove this by, I will take common side. Now AC is equal to AC. Which all angles, children, here? Angle, side. So, IAS. This is one part. If I do not want to do it like this, one more way what I can prove it here is, leave this part. By AS it is over. Since it is a parallelogram, I will tell now this side is equal to this side, which is AB is equal to CD. Then I will tell BC is equal to AD. AC is equal to AC. Common side. By which postulate? It is done by triple S. The same given sum can be proved in three different ways only if you give a proper approach to the sum. You can give or and do this way. Right? Oh, yes, one second. B is equal to D. By mistake I wrote C. So, did you understand how different approaches can be given to one sum? So, just don't stick to one thing that the teacher has done this, I will also do the same way. No, think in all wide angles. The same, if it is a parallelogram, see here how neatly we did this, but choose proper side and angles to prove it. Opposite sides, opposite angle, properties. I proved it by SAS. You can also prove this by AAS. You can also prove this by triple S, right? The same given sum is proved in three different ways and all three ways are correct, provided you write this. Sometimes some children tell me, teacher, I did the same thing what you thought, but my teacher did not give me marks. It is not that your teacher did not give you marks. You have not written same thing what I have told properly, either with reason or this, right? You always learn to blame. My teacher didn't give marks. I did the same method what you told, point to point same. But when you actually see what you have done, then you tell only this side did not write like that. It means a lot. So your teacher also knows properly. What I teach, what your teacher teach, even they know better. They'll give you marks only if it is correct. Only if the reasons are written correct. You write all this reason and write triple S and write SAS. Why your teacher should give you marks? Proper parameters written. Even a point is missing, children, here. If you do not write angle B is equal to D or you choose some other side, some other angle, it will not come in the form of SAS. How should anybody give you marks, right? It has to be done in the proper way. I want you all to do this first by SAS or by ASA, by AAS, by resolving it thrice, not there and then, and by triple S. That means your homework for today is question number 4. Question number 4, I have done it once by SAS. I have told you by two different ways which you will be redoing it in your book along with the figure. So, quickly we'll move to the fifth one. Same like in lines and angles, right? You can use linear pair, you can use exterior angle sometimes, angle sum property sometimes. Any property of this can be used. Provided use it correctly to get the answers right. There are several such sums actually which you can apply such methods and do it. Provided you should know the proper properties of the given quadrilateral. Only then it is possible. Okay, the next one. AB line segment and this is A. So this is P, B, Q and P. Line L is a bisector of angle A and B is any point on L. BP and BQ are the perpendiculars from B to the arms of A. Write down, let us first write down given L is the bisector of angle A. So what do you understand if it is a bisector? Okay, we have to name. So QA angle QAL is equal to angle PAL, right? So, okay, L you want or QAB we will use it, children. I think it will sound better. Angle QAB is equal to PAB since L is a bisector. Next they have given here is BP is perpendicular to AB and BQ is perpendicular to AQ. It is 90 degree. Very simple. Let's do this orally now. We have to prove the triangles are. I'll give you this as homework. Looking at the sum only we can see. We can prove that two triangles are. Triangle APB is equal and congruent to triangle AQB and BP is equal to BQ. B is equidistant from arm of angle A. So B is equidistant from the arms of angle A means, okay, I'll tell you that what also next later. BP is equal to BQ. So B is equidistant. That is what, if it is equidistant, we could prove that. Or both are same thing here. How do we prove this congruency now? We already have one angle equal. Then in these two triangles, what else do you have? You have another angle equal. Why? Bisectors given. Now see, already two angles are done. So we are only left with these two. Whenever we have two angles, think of only ASA and AAS. Two angles are there. One more side I want. Which is that? Common side. Read the angle. Angle side. So it can be done by AAS. From this, can we say that BQ is equal to BP by CPCP? That's all. I think it's very simple. You can mark the sum for homework. Fourth one I have given you homework, children. That is already I have done it. You have to do two different methods. Fifth one as well I have given. Very simple. It's by which postulate I have discussed also. We'll move to the next one. Yes. Now next three, or you can say the next two writers which we are doing, we apply axioms here, what we have studied. Which axiom? Let us see here. That is why I told you, right, that's very important concept which we use in geometry. Draw the figures neatly for these type of sums. So the first is this. I'll read this as A, B and D. Then from D we have another one. So this is E. E comes here. That is C and I have that to A. So let me have some more space here. Okay, so this angle is equal to this angle. Look at the marking. Anything else? Just mark the signs, whatever is mentioned, we will write it. This is what given. Let's write accordingly. Sixth one, given. So it's a quadrilateral, but don't write anything. Write down whatever is given. AC is equal to AE. Where is AC? AC is equal to AE and AB is equal to AD. They have also given two angles equal, angle BAD is equal to angle EAC. To prove, BC is equal to DE. Now children, here of course we can prove that BC is equal to DE by congruency only. Now you want two triangles for congruency. First of all, if they have given to prove that these two triangles are congruent, it is very easy for us to choose the triangles. But now difficult to choose because they have not mentioned which triangle, but we still have a hint. What is that hint? Sides. DC and DE is given. Just check the side BC lies in which triangle. So to prove part, in triangle the side BC lies in which triangle? ABC. That's the hint. That is how I got to know I should choose ABC. Okay. The side DE lies in which triangle? And triangle ADE. Okay. So we have chosen. You want, you can draw it separately. See here. So this is A and this is A, B and C. Now where is your ADE? Let me draw this with dotted lines if you want. So this is what triangle we have chosen. A, D and E. Okay. So it's very easy now to see. Let me also mark. So here in triangle, if I say here in AB triangle, this is equal to AD. Now I think it is very easy to identify. Then what is equal? AC part is equal to DE part. Two sides are equal there. Now look at the angles, children, here. What angle is equal? This angle is equal to which angle? AED. This one. It's actually this one. EAC it is? Yes, EAC. Right. It is this angle. Okay. So markings are very simple. With that respect, we will write here now from the given part. AC is equal to AE. AB is equal to AD. Given. What angles they have given in this part of triangle? Angle BAD is equal to angle EAC given. Over by SAS can we say? No, we cannot say. Why? Because it is not a complete angle, children. It should have been this whole angle, but it is not. And this should have been this whole angle, but it is not. It is part of the angles. Using part angles, we can't prove that by SAS. We know it is SAS only, right? But the part angle is missing. Which part is missing? In both the angles, which part is missing? Can you see that this part is missing in both, right? If I add that part to both the sides, what will I get? See here. BAB is there, but I want whole angle BAC. That means this part. What is this? DAC is missing. Check in this side also. EAC is there. This is there. This part is missing. Which is this? DAC is missing. So in both the parts, DAC is missing. Can I write here angle BAD plus angle DAC is equal to angle EAC plus angle DAC. Which axiom? Axiom 2. If equals are added to equals, the wholes are equal. BAD plus DAC. BAD plus DAC is read as BAC. Is equal to EAC. EAC plus DAC is read as how? DAE. This angle plus this angle, if I add whole angle, DAE. Right? Therefore, what is this? Triangle ABC is equal and congruent to triangle ADE by SAS. S. From this, BC is equal to DE. CPCD. Did you understand now how we added that part? Yes. Similar is the next sum also, which we are doing where we add it. So be very careful. Only with this given, if you say this says the whole theorem is wrong, because you need to prove the whole part of the angle, not part of the angle. Quickly, we'll finish with the seventh one. Seventh one, how is it given? A base AB is given. Okay. This angle is equal to this, as well as this angle is equal to this. So this is P, this is E, and this is D. Let me write quickly the given part. AB is a line segment, P is a midpoint of, P is a midpoint, or simply I will write here given P is the midpoint of AB. That means AB is equal to BB because it's a midpoint. Next part. D and E are the points of the same sides of AB such that angle BAD is equal to angle ABE. So that's what we have marked. Angle BAD, that is this angle, we read it, is equal to angle ABE. Both angles are marked. And angle EPA, that is EPA, is equal to angle DPB. To prove triangle DAP, see when triangles are given, no, don't worry, choose that triangle only to prove congruency. Only when they are not given, the hint in the previous sum I told you, is equal and congruent to triangle EBP. One more thing also, yes, of course. How do you prove the second part? CPCD. Don't worry about the sides and angles asked. It's always by CPCD. So AD is equal to B. Proof. Choose the same triangles. In triangle DAP and triangle EBP. EBP, right? Yes, EBP. Let's draw them first. DAP. Where is DAP? DAP. So DAP is here. So this is A, this is D. So according to me, this is equal, right? This part is equal, only the DAP. See, it is equal, but this part is missing. What is that part? DAP. Only this part here, only the half part is not there. So I can't even mark the angle P. Where is angle P? It is here, children. This part of angle is equal. So this is E. This part will go here now. Did you understand this? Okay. Next part we will write which triangle they have asked. EPB. Where is EPB? EPB. This triangle we have to draw. So let me draw this. Extend this here. This is B. This triangle is equal. According to them, what they have given. One more angle is marked. Where is that angle marked? Let me draw. So this part of angle is equal. Right? Both the parts. I have just drawn in dotted lines to understand. But this part is missing. Did you see that in both the triangles? So that part is missing to form a complete triangle, right? Okay, we understood the figure. Let's start with this now. So first what we will do, whatever is equal, shall we write that? Okay, P is a midpoint we know. So we will first write AP is equal to BP given. Then BAD is equal to angle ABE. Reason given. What its angle is equal? EPA is equal to angle DPB over two angles and a side. We call them as ASA. Shall I tell ASA? But that is not a complete angle, no children. Why? Because if DAP is a triangle, I should get the whole angle. What is missing? This part is missing. Okay. If EBP is a triangle, I should get here. See, I am again drawing. I should get the whole triangle. But that part is missing. Right? What we will do? So we will add that angle. What is that angle? EPD is the angle. So angle EPA, that is angle EPA plus this EPD is equal to angle DPB, that is DPB plus EPD. Reason? Axiom 2. Equals added to equals, the whole are equal. Read this. EPA plus EPD, what do you get? APD you get. Is equal to, you get this as DPE. Read. Angle, side, angle. First time I think we got ASA congruence rule. Therefore, triangle, where is it? DAP is equal and congruent to triangle EBP by ASA congruence rule. From this, can you tell now AD is equal to BE? Right. Is equal to BE. CP, CT. Clear? Figure is a bit complicated, but if you understand it, it is very simple. And the last one of this exercise. So there are many things to prove here. It's most usually asked. This sum is most usually asked in your exams. It can be for 3 or 4 marks because there are so many parameters to be asked, and all the parameters are not done by simplicity here, children. If you can see, it is something congruency you have to prove. You have to prove one right angle. One more congruency you have to prove here. Then something, a given line is half of the another line. So it is not very simple. You prove one's congruency and say by simplicity everything is equal. By simplicity you can only say the sides and respective angles are equal. You cannot prove it is 90 degree. So let's see the last one. So we'll have a diagram here. So B, C, N, D and A. In right triangle ABC, right angle at C given. So what is given? In triangle ABC, angle C is equal to 90 degree. This much we know. M is a midpoint of hypotenuse AB, right? M is the midpoint of hypotenuse AB. M is the midpoint of hypotenuse AB means, can I say, I'll write here only. This implies BM is equal to AM. These both are equal because M is the midpoint of hypotenuse AB. This is 90 degree, children, given here. If this is 90, this need not be 90 because your figure tells it is a straight line, it need not be 90. Don't go by what you can see in the given figure. You can only say only after proving it. Okay, that part is done. And M is reduced to point D such that DM is equal to also CM. Okay. Also it is given that DM is also equal equal to CO. They have given it. Point D is joined to P. To prove. I will not write to prove here because it is a quite lengthy sum. There are 4 parameters, children, so you can write it down to prove here. First one, second one, third one, and fourth one. That will take lots of space if I write because I want to complete this in one board only without erasing it. So first of all, they have given us which triangle to prove congruency. Let's start with it. Proof. So in proof, the first what they have chosen is in triangle AMC and triangle BMD. Which is that? AMC, this and this triangle they have asked us to prove it. Okay, first of all, let me mark this side is equal to this side. This side is equal to this side. Why? It's given. Then this angle is equal to this angle. Vertically opposite angle, SAS. Let's do that quickly. So I will write here AMC, right? Yeah, be very careful. AMC triangle. Write that triangle side first. AM is equal to BM. Then CM is equal to DM. Given. Angle AOC is equal to angle BOD, vertically opposite angle. So therefore triangle AMC is equal and congruent to triangle BMD by SAS congruence rule. Right, from SAS congruence rule that these two triangles are equal. Now they have not asked, but we need to write CPCT here. Now, what is CPCT here? From this one part, I can tell that angle ACM, that is this angle, is equal to. Now, ACM is opposite to AM side, so is equal to what? This one. Why this angle? It's only because AM is equal to BM. Okay, children. For AM, which is the opposite side, this one. For BM, which is the opposite, for AM side, which is the opposite angle, this. For BM side, which is the opposite angle, this. That should be very carefully written. Angle ACM is equal to angle BDM. CPCT. Okay. If you see, what are these angles actually? See, this is coming in the Z formation. Are these pair of alternate angles? Yes, these are pair of alternate angles. But these are pair of alternate angles. Therefore, if they are pair of alternate angles, can I say BD is parallel to CA? Right? BD is parallel to CA can be taken? Okay, let's consider that as it is. So, now since they are parallel, what about the co-interior angles? Now see here, that means the BD is parallel to CA. This is the transversal, which is nothing but BC. Can I say that angle B plus angle C is equal to 180? Why? Interior angles on the same side of transversal is supplementary. Therefore, angle DBC plus angle ACB is equal to 180. Reason? Interior angles on same side of transversal is supplementary. TBC we don't know. ACB is 90 given here. to what? 90 degree. That is angle B is equal to 90 degree. That is what they had asked here. This implies angle DBC is a that is what they have asked. DBC is a right angle means B is 90. DBC is a right angle. Second part we proved from this. Okay. Now they have asked one congruency here, children. Okay, if you can write down this, I can erase this and I can do, because still two more things are there. I do not want to congest here and write it. So I think till here it is understood very clearly what we have done, right? How did we prove these two triangles are congruent? With that we wrote CPCT angles. Did you understand, right? Why we choose this angle? Angles opposite to equal sides are equal. Wherever is the side, that opposite is the angle. That we proved it. We proved they are parallel. So when they are parallel and a transversal, interior angles are supplementary. With that we proved the second part. Third and fourth I will do it here, children, since I don't have play space. I hope you will have copied this down. Last two part. Okay. Now they have only given one triangle to prove congruency. Let's write that triangle. In triangle DBC and triangle ACB. In triangle DBC and ACB. First of all, write angle DBC is equal to angle ACB is equal to 90. One is proved and one is already given. Write it that much. Then, what else are equal here apart from this? This angle is equal to this angle. Anything else? Yeah. One main thing I actually forgot to write, children. Please make a note. We proved that these two triangles are equal and congruent, right? Did we prove that? What CPCT we wrote? We only wrote CPCT that this angle is equal to this angle. Can you add one more there? What? Can you add this one AC is equal to BD? CPCT please. Yes, that one point to be added. We missed it. Without that we can't be doing it here. Okay? Understood where to add? When these two triangles are equal and congruent, this angle is equal to this angle, 0.1. This side is equal to this side, 0.2. One angle, one side, we proved it. That I will write here now. AC is equal to BD. Reason? Proved above. Where above? Here I don't have, but you have in your book. Then, so this side is equal to this side. This angle is equal to this common side. BC is equal to BC. Common side. Therefore, triangle DBC is equal and congruent to triangle ACB by SAS congruence rule. Side angle side congruence rule. From this we can say that, can I say CD is equal to AB? CPCT. Done. Last part. We know that CD is equal to AB. Reason proved above. Anything what we use the above proved part, we write the same reason. How can you write CD? You can write CD as DM plus CM is equal to AB. AB also you can write, but don't split. Is DM is equal to CM? Yes, it's equal to CM. Can I write this as, we want answer in terms of CM. 2 times of CM is equal to AB. Reason? DM is equal to CM given. Send this 2 down. CM is equal to half AB. Right? Hence proof. That's all it is. So we have quite a big triangle, children, and very important. Usually I have seen them ask this. So with this we complete this exercise. We'll move on to the next exercise in the next session. Please complete the homework given.